So we're going to talk about resistance. The first thing we're going to talk about is question number 3. The diagram represents a 10-volt battery, a length of 9 chrome wire, and which has a very low resistance in a series circuit. As the temperature of the nichrome is decreased, the brightness of the lamp will. And so if the nichrome temperature is decreased, that means you're slowing down the kinetic energy, which means even the electrical current that's going through the resistor is going to slow down as well. So that means your lamp is going to decrease in its brightness. Okay, question number 5. According to the graph, we're looking at the whole graph, so that's 4 through 6, which is up here at the top. We're looking at current versus potential difference, which is your voltage. So voltage has a voltage difference, which is also known as potential difference, that goes from high to low, so meaning you're going from your power source to any device that's getting the energy. So the student concluded that the resistance of the light bulb was not constant. We can see that by the curve. That's kind of exponentially decreasing versus current and voltage. So evidence from that, we know that V equals IR, which is Ohm's law. So voltage equals current times resistance. If the voltage ends up decreasing, that means that the current is going to end up decreasing. Same thing, if I look at resistance, is a relationship between voltage divided by the current, which means that with that decrease, it has to be, in order for it to occur, it's going to have to be constant. A constant line would look like a straight increasing line. Because it's curved, we know that it's not constant. For 5, according to the graph, as the potential difference increased, the resistance of the light bulb, well, as we see here, resistance, which is going to be the voltage over current, is going to also decrease as well. And for 6, while performing the experiment, the student noticed that the light bulb began to glow and became brighter as she increased the voltage. Increasing the voltage is increasing the current, which means you're simultaneously increasing the power, so your light bulb will become brighter. Question number 12. 12 here says that it has a chart that shows you the graph between your wires, your material, your temperature. These are all the same. What starts to change is the length and the cross-sectional area, which is just like if I cut the wire in half, what it would look like. So I have a length for A, which is 0.1 meter, and then I have B, which is 0.2 meters. So I have doubled in size. For the cross-section, I have one that is a total area of 0.010 meters squared. And for the other one, it is larger at 0.020 meters. So when we look at this 0.1 and 0.01, 0.2 and 0.02, we've actually doubled the length and the diameter of the size. So if wire A has resistance R, then what will wire B resistance pretty much be? Well, I've doubled from A to B, but we got to look at the resistance and what's occurring. So if I look at this one, I'm at 0.1 meter, so which means I have a fairly low resistance. So I'm just going to put R as low. Now, when I have this very small cross-section, that means that the area is smaller compared to this, which means your resistance is going to be high. So because it's only a small area, you have a lot more compaction, and it's really difficult for the current to flow through. Smaller wires have higher resistance. Larger wires have less resistance. So that means in here, the resistance is lower. If the length of the string is longer, that means that I have more stuff to get through and go through. So that means my resistance here is going to be greater. So they're opposite based on the resistance. Longer wire, greater resistance. Smaller wire, lower resistance. And smaller area, higher resistance. Larger area, smaller resistance. So because this is an increase by exactly double from 0.02, the ratio to this is 1 to 1 for each of these, which means that R for the resistance for this is going to be exactly the same. It's going to be R as well. So our answer for that should also be 1, which means it's just R. There's no increase, you're not multiplying, it's not doubled, it's just going to stay the same. Okay. 17. Which changes would cause the greatest increase in the rate of flow of charge through a conducting wire? So your answer should be increasing the applied potential difference and decreasing the length of the wire. So making this wire smaller gives you less resistance, and increasing the potential difference means that you're increasing the amount of power and the amount of voltage. Okay, question number 22. Pieces of aluminum, copper, gold, and silver wire each have the same length and the same cross-sectional area. Which wire has the lowest resistance at 20 degrees Celsius? And that's just going to be copper. So make sure that you know what types of wires are going to produce the least amount of resistance. Question number 36. Which change decreases the resistance of a piece of copper wire? And of course, decreasing the wire's temperature is going to end up decreasing the resistance. Okay. All right. Next is going to be Ohm's law for